Higher order derivatives. In this video, we will learn how to repeat the process of differentiation to obtain derivatives of derivatives. There is higher order derivatives. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. If f of x is a differentiable function, then its derivative is also a function. Since the derivative f prime is a function in its own right, we can compute the derivative of f prime, called the second derivative of f. Let us see how it works. Consider the function. Find the derivative of the function. From now, we should refer to this derivative as the first derivative. We can use prime notation or Leibniz notation. We can read these as f prime of x and df by dx, or simply the first derivative of f of x. We can see that the first derivative is also a function, so it can be differentiated again. The derivative of a function is called the second derivative, or the second order derivative of that function. We can read these as f double prime of x and d2f by dx squared, or simply the second derivative of f. Again, this is a function, so we can differentiate it again. The derivative of the second derivative of a function f is called the third derivative of f. We can read these as f triple prime of x d3f by dx cubed, or simply the third derivative of f of x. This differentiation process can be continued as long as the resulting derivative is itself differentiable to find the fourth derivative, and so on. Any derivative beyond the first derivative is called the higher order derivative. Because the prime notation for higher order derivatives would eventually become somewhat messy, I prefer to use Leibniz notation. The derivative of a function f of x is itself a function, so we can repeat the process of differentiation. The result of taking the derivative n times generates the nth derivative of a function, provided that all those functions are differentiable, which is denoted by one of the symbols. Derivatives after the first derivative are called higher order derivatives. The higher order derivatives are denoted as follows. Let's see how it works. Find the first derivative and all the higher order derivatives of f of x. To start, we need to find the first derivative, or simply the derivative. To calculate the derivative of the above function, we will use multiple derivative rules, which include sum and difference, power and constant rule. The key to finding derivatives beyond the first order is to just keep taking the derivative. The first derivative is a function, so we can differentiate the first derivative to get the second derivative. The second derivative is a function, so we will calculate the third derivative by differentiating the second derivative of the function. The third derivative is a function, so we can differentiate this function to get the fourth derivative. The fourth derivative is a constant, so we can apply the constant rule to get the fifth derivative. Because the derivative of the constant is 0, so the fifth derivative will be 0. Now the function cannot be differentiated any further. Let's see the next example. Determine the second derivative of the function. To compute the first derivative of this function, we begin with the chain rule, followed by the exponential rule and the power rule. To compute the second derivative of this function, we begin with the product rule, followed by the chain rule, the exponential rule, and the power rule. Pay attention. Let's see the next example. Determine the third derivative of the function. To compute the first derivative of this function, we begin with the chain rule, followed by the derivative of the natural logarithmic function and the power rule. To compute the second derivative of this function, we apply simply the quotient rule. In order to compute the third derivative, it is convenient to write this function as a negative power, so as to avoid the quotient rule. Then we apply simply the power rule. Let's see the next example. Determine the fourth derivative of the function. To compute the first derivative of this function, we begin with the chain rule, followed by the derivative of the sine function. To compute the second derivative of this function, we begin with the chain rule, followed by the derivative of the cosine function. To compute the third derivative, we begin with the chain rule, followed by the derivative of the sine function. To compute the fourth derivative, we begin with the chain rule, followed by the derivative of the cosine function.